So Newton's Cradle part one, we pretty much derived all these equations, and these equations are pretty much what you're going to need to understand some of Newton's Cradle. All right, so let's look at a problem. Let's just say that we do have Newton's Cradle here, and that we are able to measure. We measure some angles and we measure some other stuff. So this is A, B, C, and D, and of course this is D. Of course this is A. Should probably make that like that. So we would know some things. We wouldn't know this angle. If we knew this angle was 45 degrees, and we had a little protractor here, and we let this fly, and we saw that, hey, that this ball D gets to 45 degrees, we can start figuring some stuff out here. Let's say that we don't even necessarily have to know how high you would. I mean, you could figure out how high you'd have to bring A to get 45 degrees over here, but that is in the same sense the theta that we're looking for. So we know that all the masses are the same, so we can go back to this. We can go back to this equation that velocity prime D is going to be equal to 1 plus E divided by 2 cubed times velocity A. So let's just say that we pull this ball back, it gets 45 degrees, and we notice that there's a 10% loss in velocity. I don't care how you do it, with a laser or with a radar, or whatever the case may be. You know, if you figure out the velocity from this equation right here, if you can figure out this velocity, you know that this velocity D is 10% less. So as in the last video, we say, hey, well, that means that 1 plus E divided by 2 cubed is going to have to be equal to 0.90 because of V, because D is 90% of V. It's 10% less, or it is 9% of V. So that would mean that 1 plus E divided by 2 would have to be equal to the cube root of 0.90. And then we multiply that times 2, so the 1 plus E is going to be equal to 3 cube root of 0.90 times 2, right? And then we're going to subtract 1. So the E basically becomes to 3 cubed root of 9.90 times 2 minus 1. E then becomes, numerically, becomes about 0.93, 0.97. I mean, it goes on forever. 0.97. I mean, I don't want to deal with it. But anyway, that's our E. So we can kind of guesstimate about what our E is going to be. So now we know E, we can say, well, let's find out what this sign here, let's find out what this is going to be. We know our E now. So let's find out what this sign, how far back should we bring this A to get 45 degrees over here if we're losing 10% 10% in our velocity due to resistance and whatnot. So that would mean my velocity D, velocity prime D is going to be equal to 1 plus 0.93 divided by 2 cubed. Now this is going to be like times 2 times G times L times 1 minus the sign, which we're looking for, square root. Right? Square root. Well, we don't know that. So we can actually find it from here. So if we know this sign, and we know this sign to be 45, we can figure out this sign. So let's do that. So we don't know what this is yet. We don't know what this is what we're looking for, but this will give us our velocity D. I know it's 10% less than our velocity A. So let's do it. So that sine 45 degrees is going to be equal to 1 minus R1 plus 0.93 divided by 2 raised to the 6 times sine, 1 minus sine, sorry. 1 minus sine, and this is the sine we're looking for. All right, so we say that 45 degrees minus 1 is going to be equal to this thing here, which is, this thing actually becomes negative 0.8, so this would be negative 0.81 really, and that's going to be times 1 minus sine theta. Right? So we can divide both sides by 0.81. So we're going to get a negative 0.29 is going to be equal to this thing here is 0.29 times, I think I'll just do it this way. I mean, I don't have to do it this way, but I'm just going to do it this way anyway, because it can work out. You can do it either way. You can divide this by 0.81, but I'm just going to do it this way. 0.18 minus, or rather plus 0.18 sine theta. I just distributed it. That's basically what I did. So this becomes negative 0.29, 0.29, right? Then we're going to plus 0.18, and then we're going to divide by 0.18, and that's going to be equal to our sine theta. Right, so we're going to do the inverse. This comes to be, this number becomes 6 point something, 0.63 something equals our sine theta. And theta comes out, if you do it in radians, it comes out, after you do the radian conversion, it comes out to be 39.62 or 672.67 degrees. So now we know that to have 45 degrees over here, we need to bring this up to 39.67 degrees. So we know if we don't even measure this side and we measure this side, we know that this side's going to be 39.67 degrees. All right, so now we found that. That means we can find velocity in D. All right, so let's put that into there. Let's put this thing into this thing and see what we get. So without doing all the math and all the kind of good stuff, it's just a matter of just putting that number in there. We are going to get that our velocity d prime is going to be equal to approximately, this thing here becomes 0.9, and this becomes 0.9, right, because with this 90% of this velocity, and this comes out to be about times 3 point something, 3.03, 0.35, and then our velocity final, our velocity d is going to be equal to about 2.73. 73. Now, rewind, 2.73. Okay. So let's think about this in the next steps. All right, so we know velocity d, and we know that velocity a has to be 10% greater than that, right? So how do we do that? Well, if we plug this 39.6 something into our velocity a, we're going to get about 3.035. So we know that this is going to be 3.035, right? I didn't really put this in meters or anything. I mean, I could. I mean, if you want to, you could make this length. I think earlier we said this is equal to 1.3 meters. I mean, you can if you want to. I'm more or less looking at the fact that this is 10% less, right? That this number is 10% less than this number. All right, so there's a little pattern now that we can start thinking about. If D, now when D swings back, right, to A, that means that the next A, the next A that this comes up as this D swings back, you're going to have an A. It's going to be 10% less than this number. Then as this swings back, right, it's going to be 10% than that number that we found. Well, there's a pattern that we can use there. There's a pattern that ends up going. What is that pattern? Let's see that pattern. Let's work it out. And if this pattern works, then we can get somewhat of an accurate, I would say more precise. I wouldn't necessarily say accurate, but we'd probably get a pretty precise reading. So let's look at this. So our velocity A is equal to 2 times G times L times this 1 minus that sine of that 39 point something. 39 point, I think it was 6, 7 or something like that. Right? And if we take the square root of that thing, right, we're going to end up with 3.035, really, 0.35. Right? And then so velocity D, right, we take the 10% of that thing, and we realize that our velocity D is really just going to be 1 plus 0.93 divided by 2 cubed of velocity A, right? Because it's 90% of this thing, and that ends up being 2.731. 2.731. Well, then it's going to go back to velocity A because you're swinging it back. So what would be my velocity A? Well, this is going to be the same game, right? So I'm going to have, actually it'd be velocity, no, I'm sorry, it would just be velocity A, which is going to be equal to 1 plus E divided by 2 cubed of what? Of the original velocity A? Well, what would that be? That would be this thing right up here, right? So we're going to end up with this is going to end up being 2.45, right? And then it's going to go back to velocity D, right? Velocity prime D. I'm sorry. So this is velocity prime D. It's the same game. We're just going to continue this over and over and over. And what happens is what happens to our situation is that this actually becomes where you're going to add up. You're literally just going to literally add up. So my velocity prime D is going to be equal to my addition of, we're going to say n equals 1 to infinity. I don't care what it is. Of 1 plus E divided by 2 to the n times VA. And this is what you will find if you use 10%. Like if this E is equal to 0.93 as we decided, then this will work. This will show you that each time this comes back here, every time this comes back and swings back and forth, each one of these velocities is 10% less than the other velocity. It's 10% than this velocity. As this swings back, it's 10% less than this velocity. As this swings back, it's 10% of the velocity that it came in with. So really, this is an equation that's going to show you if you're losing 10% for each time that the ball hits the other ball, then this equation will solve that problem for you. It will show you what the velocity is after whatever, how many hits you want, how many impacts you want. So N really is how many impacts there are. N equals impacts. So if you have 10 impacts, you go between 1 and 10. At the 10th impact, you should have a velocity of whatever, and 1 plus E divided by 2 to the 10th times VA. And it will give you it'll give you pretty close to what it is. I mean, it'll be going back and forth. The same thing can be said for this equation. This equation basically was going to come down to sine prime is going to be equal to, and if we add it all up, n equals 1 to infinity, right, of n plus, or 1 plus E divided by 2, right, raised to the 6th, raised to the n, times r 1 minus sine 45. 1 minus sine 45. This thing here will give you each one of the thetas at each impact. So at each impact is as n equals 1, the first impact, n would be 1, would be to be 1 plus e to the divided by 2 to the sixth. At the second impact, this would be 1 plus e divided by 2 to the sixth squared. At the third impact, you follow me, and it will give you, eventually, it will give you each one of these signs. It will tell you eventually what this sign should be. And through experiment, it does work. So, if you think about these equations, let me write them out neater. If you think about these equations right here, this is all the equations you're going to need. All the equations you're going to need to decipher Newton's cradle. So you're going to be velocity prime d is going to be equal to your summation of n equals 1 to infinity of 1 plus e divided by 2 raised to the n times your VA. And that will give you how many impacts. It will give you the velocity of, say, 10 impacts. If you put 10 in your n, at that 10th impact, that should give you the velocity at d. The same as with your sine. What sine is it going to be after 10 impacts? Well, then that would just be your sine theta prime, this thing here, is going to be equal to your summation of n equals 1 to infinity of your 1 plus e divided by 2 to the sixth to the n times the 1 minus theta, which is, in our case, it's 45 degrees. In this particular case, it's 45 degrees, but you can put theta in there. Whatever this number is, not, this is going to be theta prime. Whatever this number is, you can just put it in there and you'll get that. So these two equations right here pretty much are going to break open your... So there's all the equations you're going to need to have a fairly accurate, more precise answers for your velocities and your thetas. Anyway, I hope it helps. It's fun. I'm probably the only person right now in the United States that's caring about Newton's cradle. So anyway, I hope this helps you, and please like and subscribe.